right, we've got 1, 2, 3, 4, 5 hydrocarbon groupings. There's no indication of double bonds or triple bonds, so that's simply pentane. Pent is the 5-carbon chain. Ane is the all single bond.
So you do nothing with like the...
Not for this. No. Okay. All right. This is the sulfate anion, and you just name it sulfate. Okay. And on the front we got sodium. Sodium only has one oxidation number, so we don't need a Roman numeral. This is just simply sodium sulfate. Okay. Scandium and chlorine. Monoatomic anions have an IDE ending. Scandium only has one kind of oxidation number, a 3+. Okay? And the way that we taught you to do that is, if it's in this column right here, with a rare exception for hydrogen, they have a 1+ charge. In this column, it's a 2+ charge. In this column, 3+. This is 2+, and that's 3+. Although mercury can have more than one oxidation number. Okay, but you have to memorize that one. Okay? And then monoatomic anions in this column 1 negative, in this column 2 negative, in this column 3 negative. Alright. So this is simply scandium chloride.
Wait, why did it be trichloride?
Why would you put O?
You use the prefixes di, tri, tetra, penta, so forth, only for covalent compounds. And this is a metal-non-metal combination that's ionic. Okay? Now this is covalent. This is two nonmetals bonded together. Phosphorus is a nonmetal. It's located right here. Remember, your stair step is right here. Starts between boron and aluminum and does this. And that divides the nonmetals on this side from the metals on this side. So phosphorus and chlorine are nonmetals, so we're going to use prefixes for this one. This is phosphorus. The first element always gets named what it is. The second one will get named with an IDE ending, but we use a prefix penta for 5. So phosphorus pentachloride. Okay? All right, now this is the one you spent some time on, and you should. This is a little more tricky. All right.
Can we go back to the last one?
This one?
Pentachloride.
Mm-hmm.
Why, in comparison to the scandium chloride, do you use the prefix?
Because it's covalent. This is ionic. This is covalent. Different set of naming rules. The only thing that's the similar thing is the IDE endings and, of course, the base names for the elements themselves. All right, so you got to know that there's no carbon on any of this line. Okay, this is just simply a bond from this carbon to the oxygen. So we've got 1, 2, 3, 4, 5 carbons. So in this skeletal drawing system, corners and ends of lines signify where a carbon is located. 1, 2, 3, 4, 5 carbons. That's a pent root name. Okay? We've got one suffix functional group here. That's a chloride or chloro group. And so we're going to put that on the front. So that's chloro. We've got 2 suffix names. We've got a double bond, which is an ene suffix, and 2 alcohols, which are all suffixes. Alcohols are more important than the double bonds, so we'll name that last. This goes on the very end of the name. So let's put pent and ene, and then OL at the very end. Now, the reason I didn't put ENE is because it's not at the end of the name. If ENE was the most important functional group, and at the very end of all this, it'd be ENE. Okay? Now we've got to number everything. All right? So chloro, the most important functional groups are these alcohol groups. And what we want to do is a number, so we got the smallest numbers overall to the most important functional groups. So if I number it from this side, the alcohol group is on 1 and 3. From this side, it's 1, 2, 3, 4, 5. And so 1, 3 is smaller than 3, 5. Okay? So we're going to number from this end. So our alcohols are on 1 and 3. 1, 3. And since there are 2 alcohols, it's diol. Okay? And then the ene group is on 1, 2, 3, 4. So pent 4 ene. And the chloro group is on 1, 2. So 2 chloro, pent 4 ene, 1, 3 diol. Okay? Alrighty, let's go down here. Perchloric acid. Chloric. The IC ending on the acid name means that it comes from one of two things. It could come from a binary acid, but that would only happen if hydro is on the front of the name. Since hydro is not on the front, this ic ending does not signify a monoatomic anion. This ic ending in this case signifies a polyatomic ion that and the polyatomic ion has an ATE ending. So we're looking for a perchlorate ion, and perchlorate is ClO4. Now this perchlorate has a 1 negative charge. I'm not going to write it here right now, and I need to put as many hydrogen ions, which have a 1 plus charge on here, as I need to neutralize that. Hydrogen ions have a 1 plus charge. This perchlorate has a 1 negative charge, so you only need 1 hydrogen, and this is perchloric acid. Yes? Never mind?
Yeah, I was about to ask why you didn't put the H on there.
Okay. So this is one of the strong acids. We said you can tell it's a strong acid when it has a polyatomic ion if you have 2 or more oxygens than hydrogens. Okay? Aluminum nitrate. Aluminum is this. Nitrate is one of the polyatomic ions you're supposed to memorize. Aluminum has a 3 plus oxidation number, and that's one you just have to memorize. Nitrate, you have to memorize its formula. It has a 1 negative charge. So I need 3 nitrates to neutralize the 3 plus charge here. So I put this in parentheses and put a 3 after. Aluminum nitrate. Okay? Pentane oic acid. Pentane means there's 5 carbons in the chain and only single bonds between the carbons. We can do that a lot of different ways. You could have written a skeletal structural formula, condensed structural formula, or a complete structural formula. Let's start with a complete structural formula. Pent means I have 5 carbons. 1, 2, 3, 4, 5. The oic acid means that this carbon has to have a double bond to an oxygen and an alcohol group. Okay? And then all the other carbons get the number of hydrogens they need to have 4 bonds on each carbon. Alright, now this carbon has 4 bonds because this is a double bond. So 1, 2, and then 3 and 4. Okay? If I were writing this as a condensed structural formula, I'd write CH3 for this grouping, CH2 for this one, CH2 for this one, then CH2 for this one, and I'd probably write CO2H at the end. Or you could write it as C double bond, then OH on here if you wanted to. Okay?
Why do you put,
If I'm writing it in a skeletal structural form, 1, 2, 3, 4, 5 carbons, double bond to an oxygen, and the OH group on there. And technically, you don't even need the hydrogen on there. So any one of those 3 is probably acceptable. Not probably, they are acceptable. Okay? All right, dinitrogen pentoxide. The prefixes here tell me that this is a covalent compound, and surely you know that nitrogen and oxygen are non-metals, so covalent makes sense. Dinitrogen means I have 2 nitrogens. Pentoxide means I have 5 oxygens. Magnesium iodide. Magnesium has a 2 plus charge, and it only has 1 kind of oxidation number. It's in column 2. So you don't need a Roman numeral for this either. It's just magnesium. Iodine has a 1 negative charge, so I need 2 of those to neutralize the 2 plus charge on the magnesium.